Next, we will begin our introduction to the Pandas data structure called a data frame, which is basically an enhanced two-dimensional array data structure. Now, unlike two-dimensional lists or two-dimensional NumPy arrays, Pandas data frames can have customized row and column indices. They also offer a bunch of additional operations that make them particularly useful for data science oriented tasks. A key aspect of Pandas data frames is their support for missing data items. And as you are going to see in a data frame, every column is itself a series data structure. And those series can actually have different element types. So it is not uncommon when you are looking at a two-dimensional Pandas data frames to have many different types of columns within that data frame. So let's go ahead and switch over to a terminal window and let's begin taking a look at the concepts of creating data frames and customizing their indices. And we will do this in several parts here as we work our way through some of the data frames fundamentals. So of course, to begin, we do need to import the Pandas library. So import Pandas as PD, and just to save me typing time, let's go ahead and create a dictionary from which we are going to create a Pandas data frame. So in this case, we have a key value pairs where the keys are strings and the keys of course, have to be immutable values. The values for each key are grades in this case. So let's create that dictionary and then let's turn it into a data frame object. So data frame is the name of the class in Pandas, and we are going to pass it the grades dictionary object that we created up above. And of course, when we then evaluate grades, we can see the representation of that dictionary converted into a Pandas data frame. So it's a kind of interesting what happened here. The keys became the column names and the values within each columns or each individual person's three grades that were specified in these lists. Now, each of these lists has the same number of elements. However, let's say that one of the list was only 2 elements long. In that case, there would be a missing value when you compare that list to all the other ones which had linked 3. So Pandas would automatically put a value into that element in the corresponding column that represents no value, and we'll see examples like that as we proceed through working with Pandas data frames in our intro to data science videos and also in some of our higher end data science and artificial intelligence case studies as well. Now it is possible to also create a data frame and give it a custom index. So in this case, we didn't give it an index, so it just used 0, 1 and 2 as the row indices. And so what we could do is go ahead and add an index to the existing grades array to customize it, or grades data frame rather to customize it. So we could do to that through the index attribute of the data frame that we have already created. Now the index corresponds to the rows in a data frame. So if you were customizing the columns, there is a separate attribute that you can use specifically for the columns. But the index is always for the rows and the data frames. And here what we are saying is rename these indices from 0, 1 and 2 to test1, test2 and test3. Now we could have used an index keyword argument up here and given it the list of 3 values as well. That also would have customized the index. So after doing that, we can see that we have this nicely formatted grades data frame. We see the names of our students across the top. We see the names, the test down the left, and you also get this nice overall formatting that's automatically created for you when you get the stream representation of a Pandas data frame. So if you think back to working with the nested list structure to create a two-dimensional list, we could have to iterate on our own through all the rows and columns and do all of our own formatting to produce something like this. But here we can simply evaluate a data frame and it will automatically give us this nicely formatted output, which makes it super convenient for working with data that is structured into rows and columns. Next, let's take a look at accessing a data frame's columns. So, unlike a typical two-dimensional array or list structure where the set of square brackets that follows the array name or the list name is going to represent the index of a row in the context of data frames, that set of square brackets represents the index of a column. So for example, if I go ahead and say grades sub eva with an argument of the string eva here, that's going to select this entire column for eva, and it's going to return that to us as a series object with the customized indices that you see down the left hand side of the data frame here. So if I go ahead and press enter, you can see I get the series formatting. There is the three values from the eva column. There are the custom indices from the left side here of the grades data frame. And we can see that the name of the column was eva and the data type of the data within that column was the non-pi type int64. Now, just like with the series, if the column names are valid Python identifiers, you also can access those columns via attributes that have the same name as the column index. So for example, if I want to grab the SAM column here, I can go ahead and say grades.sam. So, and when I press enter, you can see once again, I get the three grades for SAM with the customized indices, and it tells me specifically which column I grabbed and what the data types of the elements in that column are. Next, let's take a look at accessing the rows within a data frame. So I'm going to go ahead and paste in a snippet here. It turns out that the data frame has a couple of different attributes that you can use for quite flexible indexing into a data frame data structure. Not only by row, as I'm about to demonstrate here, but also using slice notations to select subsets of the rows and or subsets of the columns as well. So here we have an expression in which we are using the LOC attribute, which stands for location, to access elements within the grades data frame, and specifically we want to access the row with the index test1. So if I go ahead and do that, it gives me back that row once again as a series. And because of the fact that we are going across the row, this time it uses as the indices in that series the column names, and as the values in that series everything in that given row. So you can see here that the row we selected was test1. The data type of the element is at int64, and once again we get that nice series formatting that enables us to explore the data for a particular test in this case. Now you can index not only by the name of the row but also by its position number. So in order to do that, I can use the ILOC instead, which says index with an integer. And let's say, for example, we wanted to get the second row, which is the row at index number 1. Because rows are still indexed from 0, whether or not you specify custom indices for them, in that case, we can go ahead and use the integer 1 here and just scrolling back up so you can see. So for the test2, which is the one at index number 101, we have 96, 87, 77 as the start. Here are those three values, and then of course the last two columns as well. So the nice thing about this attribute in particular, and this is recommended by the way in the Pandas documentation as well, is that it is not going to make a copy of the data in the data frame when you select it. There is the capability of directly indexing on the grades data frame, but some of those types of indexing operations will make copies of the data. And in some cases, that may be totally fine, But if you then go and modify the copy and you intended for that data to be stored in the original data frame, then you would have a logic error in your code. So generally, the Pandas documentation recommends when you start accessing the elements within your data frames to use the attributes LOC and ILOC for that purpose. In the next video, we will start looking at slicing data frames. In this video, we are going to start introducing the use of slices with the LOC and ILOC attributes of a data frame. Now, in the preceding part, we first showed you how to select rows from your data frame using those two attributes. Here I am going to paste in a snippet that says in the grades data frame, I would like to use the LOC attribute location attribute to select the slice that starts with the test1 row and continues up to and including the test3 row. So in this case, that happens to be all of the rows. If I scroll back up here, you can see that up above. So when you use the actual names of the rows using the LOC attribute, then it's going to produce a slice that is inclusive of the end of the slice. However, when you use the ILOC attribute and numeric indices, it's going to work the way you have come to expect from other slicing operations, which is to say it will not include the ending index. So for example, if I insert say, let's go ahead and use the ILOC attribute to select the slice of rows from index 0 up to but not including index 2. In that case, we get only the first two rows because it is not inclusive of the ending value in the slice. So again, if you are using the LOC attribute, you are going to have a slice that is inclusive of the last value you specify in the slice. And if you use ILOC, it is exclusive, which is the normal way that the notation works. Now, in addition to being able to select contiguous numbers of rows via the slice notation, you can select individual rows whether they are contiguous or not. And to do that, you can specify as the argument to these two attributes a list of specific indices that you would like to access. So for example, if I only wanted to select the first test and the last test, I could write an expression like this, where I use the LOC attribute and I pass it as an argument a list containing the indices that I want to select test1 and test3. And in that case, I get back the data frame representation with just test1 and test3 in it. Similarly, I can use the ILOC attribute and we could do a list of index numbers 0 and 2 correspond to test1 and test3, and I get the same result out of that operation. In the next part, we will start to look at selecting subsets of both the rows and the columns. You can also use the LOC and ILOC attributes of a data frame to select subsets of both the rows and the columns at the same time. And you can do that by using a combination of two slices, two lists, or a combination of slices and lists as well. So let's actually take a look at an expression that does that. In this particular statement, what we are going to do is use the LOC attribute to select the slice consisting of the rows test1 and test2. So this is a contiguous slice and it is inclusive of the ending value in the case of the LOC attribute. And then separately, we have decided for those two rows that we only want to select the columns for Eva and Katie. So if you look up above here, you can see that for Eva and Katie, the second and the fourth columns respectively. So we are going to get two rows and two columns as a result of this particular operation. And indeed, you can see test 1 and 2, which we specified for the rows with the slice, and Eva and Katie with the column just in those rows, which we specified in this case with the list. So again, the first argument is a slice here. but could be a list. The second argument is a list here, but could be a slice, and we can also use two lists or two slices as well. Now, let's go ahead and do a similar operation with the ILOC property using index numbers. In this case, we started with the list saying that we specifically want row 0 and row 2. So going all the way back up here, row 0 would be the equivalent of test 1, row number 2 would be the equivalent of test 3, and then for the columns we would like the first 3 columns, so starting from columns number 0 going up to but not including column number 3. So basically we would like to select the columns for Valley, Eva and Sam, and only for test 1 and test 3. And as you can see, and nicely because of the named indices here, you can really get a sense of the fact that we were able to select just those 2 tests for those 3 people in this particular demonstration.